So 8.1, ratios and proportions. This is our introductory lesson into chapter 8, and it's going to be a lot of algebra and pre-algebra review. So as you should have learned in a previous algebra class, ratio of A to B, this is a comparison of two quantities. We usually show them measured within the same units so that we can simplify the fractions. So we can write it with words, we can write it in fraction form, and it can also be written in colon form. And depending on what the situation is, will dictate how you write the problem. So in word situations, we use words. When we're setting up our calculations, we use the fractions, and scale factors are often written with the colon. So we're going to do a lot of work with proportions. A proportion is simply an equation that equates ratios. So when we have two ratios equal to each other, this is a proportion. The top of the first ratio and the bottom of the second ratio within a proportion are known as the extremes. The bottom of the first ratio with the top of the second ratio are known as the mean values. And when we go to solve a proportion, we use the cross product property, which you should have learned in a previous class. Remember that this property simply says that the product of the extremes is equal to the product of the means. So the first type of situation and problem that we're going to look at is simplifying ratios. So we're going to convert to get both of our numbers within the same units, and we're going to do that by multiplying by a conversion ratio. This is simply a fraction that uses the same units as our original ratio, but in opposite locations and equivalent measurements. So there's a chart of equivalent measurements here at the bottom of the slide that you see. Once we have it in the equivalent measurements, we can then simplify the fraction. Remember, when we're multiplying, that you multiply numerator times numerator and denominator times denominator. So for the first problem, we have that 60 millimeters is equal to 1 centimeter. To convert, we put the units in the opposite location of our conversion ratio. So centimeters is going to go over millimeters. And then we get our equivalent values. So it takes 1 centimeter to be the same thing as 10 millimeters. So when the units are in opposite parts of the ratios, when you multiply, they cancel each other out. So when we do our multiplication, 1 times 60 is 60, and 10 times 1 is 10. And then we simplify the fraction, and you do want to leave them in ratio form. So even though this would simplify to 6, we still write it in ratio form, which is 6 to 1. So changing feet and yards into the same unit. So we're going to use the fact that 1 yard is equivalent to 3 feet. We put our information in so that the opposite location has equivalent units. So the yards will cancel with the yards, feet will cancel with feet. We multiply, so this is 20 over 9. And then we simplify, and 20 over 9 is a simplified fraction. So for the next one, we're going to use our pounds and ounces. So we put the units in the opposite location of our conversion ratio than they are in the original ratio. We fill in our numbers, excuse me, our numbers. So it's 1 pound is 16 ounces. So the units will cancel. This is going to change everything into ounces. So we end up with 48 over 12. And then we simplify the fraction to get 4 to 1 ratio. So most of you know the relationship between days and weeks. Most of you know that it's 7 days to create 1 week. So when you put the units in alternate locations within the ratios, they'll cancel out. So when we multiply, this is 35 to 30. So 35 days to every 30 days. And then we simplify to get 7:6 ratio. Solving proportions. So once our proportion is written, it could either be a simple proportion, which has our variable in the problem one time with no addition or subtraction, or we could have a complex proportion, which may have your variable there more than once, and it may also include addition or subtraction. So we're going to use the cross product property, but the first thing you do is put parentheses around any and all addition or subtraction problems, then you cross multiply, and then we solve the resulting equation using the distributive property to remove any parentheses, and then we remove our addition and subtraction before finally removing the multiplication. The first example here is a simple proportion. You'll see that our variable is only in the proportion one time and there's no addition or subtraction. So when we do the cross product property for this one, we're going to do the x times 15, and then we're going to do the 3 times the 10. So we do the x times the 15, and it will equal the 3 times 10. So 15x is equal to 30. And to remove multiplication, we divide. So x is equal to 2. In a simple proportion, there is always the exact same calculation pattern. So in a simple proportion, you will always have one of the crosses in your cross product that contains only numbers, and those two numbers will always multiply together. And then the number that you have with your variable is always going to end up being divided to make it go away. So we always end up taking our two numbers that are in the cross together and multiplying, and then dividing by the third number. So if you can remember that quick calculation, you can answer those very quickly without having to go through the equation process. Our complex proportions, you're either going to see your variable more than once, or you can also see the addition or subtraction. So the first thing we need to deal with is all addition and subtraction goes in parentheses. Once the parentheses are in place, we apply the cross product property. So this means that the first part of my cross product is going to do the 4 times the parenthesis x plus 5. We keep that equals, and then the second part of our cross product is going to do the 16 times the x plus 2. So 4 times the x plus 5, and our 16 times the x plus 2. Now we're solving the equation because these are equal to each other. So we distribute 4x plus 20 equals 16x plus 32. To get rid of the 4x, we're going to subtract it. To get rid of the 32, we're going to subtract it. So this is going to be negative 12 equals 12x. And then we divide by 12 to get negative 1. So when you have addition or subtraction, place parenthesis around all addition and subtraction. Then when you go to do your cross product, you're going to have your two crosses, your means and extremes multiplied together. So this is going to be 2 times the y, and it's going to equal the 3 times the parenthesis y minus 3. Distribute, so 2y equals 3y minus 9. To remove the subtraction, I'm actually going to subtract the 3y. So this is going to be negative 1y equals negative 9. And when I divide by negative 1, y equals 1. Our next two examples are actually going to take and use ratios and proportions to solve geometric situations. So we're going to use a ratio to help us find missing measurements for an object. So in this particular case, it's going to be a rectangle. So we're going to use a variable and our ratio to write expressions for our measurements. We're going to choose one variable and we're going to use it in all parts of the ratio. So in this particular problem, we have the area, we have a ratio of width to length, and we're supposed to find the actual width and length calculations. So we have a ratio that says that our width to the length is 3 to 4. So what we're going to do is to get an expression for the actual width and length is we're going to put the same variable. So our actual width is 3 times x and our actual length is 4 times x. This is because our ratio is a simplified fraction that compares those two original measurements. When you simplify a fraction, you divide by a common factor. So we're just putting that common factor back in. Now, to get our equation that we're going to set up and solve, we read this is the area of a rectangle. So we're going to look back at our 6.7 formulas and look it up. So the area of a rectangle is equal to the length times the width. So we're going to fill in our values. So the area is this 192 square feet. Our length is 4x and our width is 3x. So when we solve, we do our multiplication. So 192 square feet, 4 times 3 is 12, x times x is x squared. We divide by 12, so it's 16 square feet equals x squared. And we take the square root. So the square root of 16 is 4, and the square root of feet squared is feet. So our x value is 4 feet. Now, this is where a lot of you stop. Be careful to actually answer the final question. Our final question wants to know the actual length, which is 4 times the 4 feet for x to get 16 feet, and the width, which is 3 times the 4 feet for x to get 12 feet. And if you look, 12 feet to 16 feet does simplify to make a 3 to 4 ratio. Our last example is actually using ratios to compare the 3 sides of a triangle. So we have our 3 sides of the triangle, we have a ratio, and we have measurements. So if you look, we have our 3 sides. We have the side AB, which goes with the 3 within the ratio and has a measurement of x plus 3 in the diagram. We have the side BC, which goes with the 4 in the ratio and has a measurement of 8 in the diagram. And we have AC, which goes with the 2 in the ratio and has a measurement of x plus 1 in the diagram. So what we're going to do is we're going to choose 2 sides to work with. So even though there are 3 sides on the triangle, we're only going to choose to work with 2 sides. And I'm actually going to look at the measurements within the diagram. So I see 8 is a measurement that's already calculated, and x plus 1 is a simple calculation. So when I choose my 2 sides, I choose them based on the simplicity of their measurement. So I'm going to choose to work with side BC and side AC. They have the simplest measurements in the actual diagram. So what we're going to do is we're going to take our comparison and we're going to write a proportion. So we're going to set 2 ratios equal. One of our ratios is going to use our information from the ratio itself. So we're going to use the ratio information about these 2. So our ratio that we were given said that our comparison of BC to AC was a 4 to 2 comparison. For the second portion of our proportion, we're going to use the actual measurements from the diagram. So for the second part of our proportion, we're going to use the measurements from the diagram. So within our diagram, The length of BC is 8, so the actual length of BC is 8, and the actual length of AC is x plus 1. So we take two sides and we write a proportion. So we have our ratio values for the two sides and we have our actual measurement values for the two sides. So now we're going to solve this proportion. So I put parentheses around the x plus 1, and I'm going to do the cross product in order to solve. So this is going to be 4 times the x plus 1, and it's going to equal the 8 times 2. Distribute, 4x plus 4 is going to equal 16. So the 4x is going to equal 12, and x is going to equal 3. Now this is our value of x, but make sure you actually answer the question. The question wants the length of each side. So when we go to the length of each side for A, B, we're going to do the value of x plus 3 to get 6. BC was given to be 8, and AC is our value of x plus 1 to get 4. And if you actually take the comparison of 6 to 8 to 4 and divide them all by 2, you get the ratio in our beginning situation, 3 to 4 to 2.